Now we'll talk about graphing stretches and compressions for logarithmic functions. So for any constant a greater than 1, the function f of x equals a log base b of x is going to stretch it compared to the parent function vertically by a factor of a. And then if it's a is between 0 and 1, it's going to compress it by a factor of a. It'll have the same vertical asymptote. It'll have the same x-intercept because a times 0, the y value, would still be 0. And it has the same domain and the same range. Okay, so we're going to look at a graph here. Sketch this graph alongside its parent function. So f of x equals 2 times log base 4 of x. So if I look at the original function, that f of x, or just call it, I don't know, g of x equals log base 4 of x, we know it'd go through 0, 1. We go back to blue. Go through 0, 1, or sorry, 1, 0, I apologize. If it changed to blue, it'd be really helpful. Okay. And then it would go through 4, 1, and then it would go through 1/4, negative 1. And we have this as our our vertical asymptote. No y-intercept. And so for our original, I'll say g of x equals log base 4 of x. We will have a vertical asymptote of x equals 0, which is not going to change. We have the domain from 0 to infinity. That didn't change or won't change. And we have the range from negative infinity to infinity. And that's not going to change. So we get a curve, something like this is our original. And now for our f of x equals 2 times log base 4 of x, we'll have a vertical asymptote of x equals 0. We have a domain of 0 to infinity, and we have a range of negative infinity to infinity. Okay, but some points will change. So this one doesn't. It still goes through 1, 0. And it would have gone through 4, 1, but now it's going to go through 4, 2. And it would have gone through 1/4, negative 1. It'll go through 1/4, negative 2. So it's going to look something like this. Okay, that's the graph of the stretched function. And then we'll look at one, sketch the graph of f of x equals 5 times log of x plus 2. State the domain, the range, and the asymptote. Excuse me. So if we do this in some steps, we first of all can look at just g of x equals log of x. This is common log, right? Yeah. Log of x. So it's log base 10. So it's going to go through 1, 0. It's going to go through, so this is going to go through 10, 1. So way over here off my graph. And 1/10, negative 1. Something like that. And then when you do the plus 2, that's going to move it everything to the left. So I'm going to change this color to green. So 2 to the left here. This would go 2 to the left to there. And this goes 2 to the left to there. So now our asymptote looks like it's going to be x equals negative 2. So I'll write that as asymptote x equals negative 2. And so our domain is going to be -2 to infinity, and our range will still be -infinity to infinity. Okay, so that gives me the domain, range, and asymptote. So if I draw this one, looks like it's coming up like so, and it's going to be crossing right there. Okay, so I'm going to do a little erasey, but it's going to take away a bunch. So it comes up like so. There, something like that. Now we applied the 5. So let's see what I can do for that. I have orange, I guess I can use, and red. I'll go with orange for that. By the way, our asymptote is back here. So now we know we can, if we do the 5, h of x, call it something else, is 5 times log, common log of x plus 2. So, and I probably should have written this f of x. No, that should have been the h of x. Sorry, everyone. H of x equals common log of x plus 2. So now we're going to be at, this is our f of x. So that's what we're assigned to do. So we're going to be bringing these up. So 5 times 0 is 0. 5 times 1 out here is going to be 5. And then 5 times -1 is -5. It's going to come up like this. It's going to cross through here. Something like that. Okay, that would be our graph of y equals 5 times common log of x plus 2.